other sensor for temperature that we are going to be looking at is the thermocouple, that is very common also in the process industry. The thermocouple, I think, is the most popular, okay, in the process industry. So, like the bimetallic strip that we saw the other time, they are made of two dissimilar metals too, okay. So these two dissimilar metals, when you join them at both ends and subject those two ends to different temperature, because of that difference in temperature, you see that the electrical charges will be made to flow. So the magnitude of these electrical charges or electrons that flow is dependent on the difference between the temperature of both ends. Okay, so the higher the difference, the greater the electrical charges that will flow through the thermocouple. Okay, so which means that one end of it is which is the reference point, is the cold end, and the other end is the hot end. Okay, that is the side part that you subject to the temperature that you want, which means this part of it will be in contact with your process and this part will be out of your process. So this is what we are seeing here. So that charge could be read by a voltmeter. Okay, that charge could be read by a voltmeter, and then that voltmeter is connected in line, okay, with one of the conductor. That is, the conductor is broken and then connected in line with it, okay, to the cold end. So this part that is in contact with your process, and this is the cold end now. So as the temperature is increasing, you see that the amount of current that will be flowing or voltage that will be induced here will also increase. Okay, so here we have an example of it. You see, as you are hitting, the temperature, the voltage in millivolts that will be generated will go up. So this is the thermocouple, and this is the junction box that carries these two. Okay, this is junction box where we have these two terminals, okay, that you can connect to your controller or to your transmitter. So this is how you see it physically, the thermocouple, okay. So the two dissimilar metals, they are here, and this is the two wires, okay, that takes your output voltage to your transmitter or to your controller. So this is how it is connected physically, installed physically in your process. You can see we have different thermocouples, about 3 thermocouples connected in this point of the process. Okay, so here we have the output taken to our controller or transmitter. So this is an example of what we are talking about. Okay, so once you subject this end to increasing temperature, you see that the voltage output will be changing. Okay, as you are increasing, the voltage output will be changing. So like in this case now, you see this meter gives you a direct reading of the temperature to which this thermocouple is exposed to, and that is what we are seeing here, 66.7 degree Fahrenheit, which is about 17 degrees, between 15 and 17 degrees centigrade. Okay, so that is what we also have here. So this meter is taking the place of this, okay, and that is what this gauge is doing here too. It's taking the place of this meter or this meter. Okay, so this is the physical one that we have installed in our process. Here's another example. So this is it too. So this is where we have the thermocouple connected to, this is the transmitter, yeah, indicator. It indicates the temperature of the process as read by the thermocouple and could also transmit. Are we getting it? That to either our control room or to the controller in the process to do whatever control that you need to effect within the process. So this is the thermocouple thermometer that